Alright, here we go. So we have a hyperbola day. Now these would be probably some of the more challenging ones you're going to have to face. But if you understood ellipses, honestly these are not that much different. For the work anyway. So again, you're going to have a standard form for a hyperbola, and as you can see the hyperbola form is the same as it was for an ellipse, except for the big difference is one of these is going to be negative. That's how you know you're going to have a hyperbola, is either your x squared or your y squared group is going to be negative. So you still got the same center, we still have an rx and an ry, we still have foci, but the equation to get the foci is now c squared is equal to a squared plus b squared, or rx squared plus ry squared. There's a plus sign in between this time for a reason, and you will see once we start graphing. The vertices are always on the positive axis. So let the fun begin. Again, you need to be a pro at completing the square to be able to graph these. So we're going to step through another one of these together. Get your x's together. Get your y's together. Notice our y is negative at the moment. It is not always going to stay negative. It might switch, and you'll see. And we're going to bring our negative 589. So we're going to factor out our leading coefficient of 25. X squared minus 8x. Half of 8 squared is 16. But when we multiply that by 25, we will be adding 400 to the right side. Now we're going to go factor out our negative 9. We have y squared plus 4y. Half of 4 squared is 4. Multiply that by a negative 9, and we'll be subtracting 36 from the right side. So now we have 25. X minus 4 squared. We have a negative 9 times y plus 2 squared is equal to negative 225. Just like an ellipse, we must have this equal to 1, so we are going to divide everything by a negative 225. And I think you see what's about to happen. The y is going to become positive, and your x is going to become negative now. So 25 over 225 is going to reduce to, in this case, a negative 1/9. Negative divided by a negative, so 9 divided by 225 is going to give us 1 over 25. So this is plus y plus 2 squared over 25, and we're equal to 1. Just like an ellipse, we need to extend our parentheses. So our graphing form for this is negative, big old parentheses, squared. We have x minus 4 over 3 inside, plus, big old parentheses, y plus 2 all over 5 squared is equal to 1. And that is your graphing form. Now, from the ellipse, a lot of this is very, very similar. Our center is a positive 4, negative 2. Our Rx is 3. Our Ry is 5. So we have our 4, negative 2 as our center. Rx is going 3 to the right and 3 to the left. Ry is going 5 up and 5 down. Now here's where the change happens. This is not an ellipse. This is a hyperbola. So it's as if you were stretching the ellipse like a rubber band so far that the rubber band snaps. So these are not actually going to be even connected. So what you're going to do here is you actually do dashed lines and you create a box. And then what you're going to do is you're going to put diagonals that go through the corners and the center. And now at the top it said that the vertices are always on the positive axis. So that means you look at your equation and you see x is negative, y is positive. So this hyperbola is going to open along the y-axis or vertically. So this coordinate is actually your vertex on the top, and this is your vertex on the bottom. So we're going to have two parabolas here. And this is what the equation, or this is what the graph of a hyperbola looks like. They do not ever cross these dashed lines. Those are the asymptotes that you have created. And that's what a hyperbola looks like. Now technically the red dashes and boxes don't really matter. They're only there to help you graph. So you will have to show those when you're graphing so that I know that all your coordinates are in the right spot, but the actual hyperbola is the purple piece of that graph. We're still not done. We still have to find our foci. Now the equation is a little bit different, and I'll show you why. The ellipse, the foci were always inside the stretched pieces. Well, since the hyperbola, actually the inside of the hyperbola is farther away from the center now, that's why we have plus. So we have c squared is equal to 3 squared plus 5 squared. So c squared is equal to 34. So C is 5.8 units away from the center. So since it's going to be inside the graph always, we're going to be going up 5.8 and we're going to be going down 5.8. So that's the location of our foci. So just like an ellipse, in this case the x is not changing. The x is going to be 4, but the y is changing. So the y value is a -2 for your center. So -2 plus 5.8 is 3.8. And -2 minus 5.8 is a -7.8. And now you have the coordinates of your foci. The last thing you have to do is find your two asymptotes. Now those are the diagonal asymptotes that we have going along here. The ones that go from the corners of the rectangle to the center. So for that, the only thing you have to do is this. You need a positive, so we have point slope form. We're going to do y minus the y coordinate of your center is equal to your ry over rx times x minus the x coordinate of your center. And then we're going to do the exact same thing. We're going to have y minus y coordinate of our center is equal to a negative ry over rx times x minus the x coordinate of your center. And if you haven't realized it yet, basically it's just point slope form. It's point slope. Your point is always going to be your center. Your slope is always going to be your r radius in the y, or your radius in the y direction over the radius in the x direction, also known as slope, rise over run. One's going to be positive, one's going to be negative. Same center, same slope, one positive, one negative, you're done. So our two asymptotes, the equations are going to look like this. So we have y minus, our center is a -2, so that becomes +2 is equal to, and then we have our slope, our ry over rx. We have a positive 5/3 and we have a negative 5/3. And then we have our x minus, the x coordinate of our center is 4, and we are done. Those are the two equations. Now, From here, if I wanted them in slope-intercept form, you would just have to distribute your slope and subtract your 2. But for now, let's just leave it in point-slope form. It's easy enough. Let's just keep it there. Okay? That's it. That's a hyperbola. That's a little over 10-minute explanation for one problem. Now, you have to practice this. You need to know how to be able to do all of this. So what I'm going to do is I'm going to show you one more. I'm going to show you that this one is already broken down very easily for you. You do not have anything fancy to do. There's not a lot of completing the square. This is a very easy example because look, there's no x, there's no y. There's just an x squared and a y squared. So this is 16x squared minus 9y squared is equal to 144. Divide everything by 144. And you're just going to get graphing form. This is going to be x squared over 9 minus y squared over 16 is equal to 1. So our graphing form for this equation is x over 3 squared minus y over 4 squared equals 1, where your center is at the origin. Now I would like you to graph and list all other information and see if you can do that on your own. Go. So again, we said your center is 0, 0. Your Rx is 3. Your Ry is 4. Your C value is C squared is equal to 3 squared plus 4 squared, which means C squared is equal to 25, which means C is 5. So let's start graphing. Our center, 0, 0. Rx is 3, so 3 to the right, 3 to the left. Ry is 4, so 4 up and 4 down. Create the box. Create your asymptotes that run diagonally through the corners of your rectangle and the center. Again, remember, hyperbolas open along the positive axis. So in this equation, x is positive. So these coordinates are actually your vertices. And we open up to your asymptotes. And this is the graph of your hyperbola. Now, we still need to find the foci and graph them. So this is going to be keeping our y's the same because we are going 5 to the right and 5 to the left because our C value is saying it's 5 away from the center. So this is 5, 0 and negative 5, 0. Last thing, we need to state our asymptotes, but since they have 0, 0 for the center, our asymptote equations are just going to be y is equal to a positive 4/3 x and a negative 4/3 x. Usually it would be y minus 0 is equal to 4/3 times x minus 0, but we don't need to put the zeros since it's 0, 0. Okay? No need for it. And that's it. You're done. This hyperbola is finished. So, again, it's tricky. You got to know it. You got to practice. Do your homework. Do the worksheets. Ask questions in class. You got to make sure you got this stuff down pat. Okay? This is Longo, and I'm out. See you. Bye.